Okay, folks, most of the real questions have been answered on the other two videos that we did, but that lets us now kind of run through the rest of these pretty quickly. One of the questions, what is in the United States, the typical alternating current in your home, changes direction, how often? Somehow I got this messed up. The answer to that is 60 times a second. Most of our electricity is 60 hertz, and the hertz right here, the measures the change in direction of your electricity back and forth, back and forth, back and forth. So it ends up being a sine wave, and it measures how fast it changes like that. So it's United States is 60 hertz. Other countries a little bit different. Some maybe 50. It just depends on where you are. But the United States is 60 hertz is the standard. In a transformer, the windings on the side of the transformer where the electricity enters are called the what? These are the primary windings. Right down here, primary. So the primary windings. Next one, the windings on the side of the transformer that creates the new electrical currents are called the secondary windings. Primary and secondary. When using the simulation, make sure you look closely at the scale of the graphs. What happens when you keep everything the same but increase the secondary windings? So right now I have the secondary windings at 50. I leave everything the same. I have 120 volts. Let's change the secondary windings to, let's say I change them to 500. Now I have 1,200 volts. Changed right here, changed the scale. So that means what happens if you keep everything the same but increase the secondary windings? Secondary voltage increases. Okay. Secondary winding increase, it means secondary voltage increases. If you keep everything the same but increase the primary windings, what happens to the secondary voltage? We can go right back here and try it again. Right now, this is 1200, 1200. Let's change the primary windings from 500 to 1,000. All of a sudden, your secondary voltage decreased by half. So, if you keep everything the same but increase the primary windings, what happens to secondary voltage? Secondary voltage decreases. Okay. The effect of the transformer comes down to what? We've sort of seen this. It all comes down to the ratio of the number of primary windings to the number of secondary windings. So the primary windings to the secondary windings, that's the ratio, and that's what determines what happens between your incoming primary electricity and your induced electricity that is the outgoing on your transformer. Transformer can take high voltage transmissions of electricity and step them down to usable home electricity, but what else can they do? Let's see if we can do this here. Let's change this to 100 windings, and over here's to 500 windings. What happened now? We still have our 1200 volts coming in, right? How many volts do we have going out? 6,000. So what can you do? You can transform low voltage electricity into higher voltage electricity. You can make the high become low voltage, or you can make the low voltage become high voltage. It all depends on the number of windings that you use to create your magnetic field and how many windings that magnetic field acts upon. So that ratio of those two windings determines, are you stepping up? Are you stepping down? What exactly are you doing? Okay. So that should get you through all of those questions. And I see there's been a little bit of confusion on here, but I think we did pretty well, those of you who turned it in.